It's lab day. Today we're doing the Crayon Rock Cycle lab. Now, normally we would be doing this in class together, very fun lab, but because everyone's online, I'm going to be doing this so that you guys can fill out that page. So everyone should be on the Crayon Rock Cycle lab page. It begins. Describe the formation of the three main types of rocks. You guys should have already learned about that, especially from your activities today and last class period. So go ahead and answer that. Pause the video so you can do that. All right, objectives. Describe the process involved in the rock cycle. Be able to use the physical identifications to determine the types of rock and model the process of sedimentary rock formation. So, part one, it says natural processes cause rocks to change, crumble, break, and even disappear. Use your coin or shaving device to scratch away fragments of your rock onto a paper towel. So, today for the purposes of this lab, our rock is actually crayon shavings. It takes a long time to make these crayon shavings, so I did that while you guys were working on a different assignment. And I already have the crayon shavings right here. These are our rocks that have been weathered down, okay? So you guys can actually do this activity at home if you want. All you have to do is peel off the outside of the crayon and then just shave that wax down. You can use a coin, I used scissors, whatever you want, okay? So I went ahead and I made our crayon rock pieces, okay? Are all the fragments the same size? No, they are not. So we have some that are really big. Oh, I just broke it. And some that are tiny, tiny, you can barely see them. All right, and the reason for that is that not all rocks are weathered in the same way, and not all rocks weather at the same rate. So you know how waves will cause rocks to weather down, but it depends on where the rocks are at in the ocean to determine what kind of rock will be weathered down, how fast it'll be weathered down, and things of that sort. So the answer is no, not all rocks are weathered down to the same size, and they're not all weathered in the same way. What are two ways that rocks can be weathered? Well, I already explained waves, but another option is we could say glaciers. So as glaciers move, they will actually, the ice in contact with the rock it's moving on will scratch the rock, and over a long period of time, scratching that rock will cause little bits to come off. And so glaciers and waves, running water, maybe even wind, okay? Part two, erosion and sedimentation. Erosion, so this was weathering. We weathered our rocks down, our little crayon rocks, into tiny little pieces. Now we're on erosion. So erosion is the process of moving rock fragments and minerals to different locations. For example, removing the face of a rock due to wind and rain. Please erode your rock fragments to the center of the aluminum foil. So I was supposed to do this one color at a time to create layers. I actually mixed all the colors together, kind of. So I'm gonna try and add all of the different layers at different times, but it's gonna be a little bit hard. This isn't a perfect process when it's done on Earth either. So when rocks are weathered and then eroded to their resting spot where they become sedimentary rock, they're not weathered in perfect layers, but they are in distinct different layers depending on what year they're weathered and eroded in. So you will see different minerals at different times and different layers. So right now I'm just, as I said, eroding the rock into the center of my aluminum foil. And then we can answer these questions. It says, were there tiny spaces between the rock fragments, or are they tightly packed together? If you look, there's actually a little mound. And when I look in between, I can definitely see spaces, especially between these ones on the outside. So there are spaces in between the rock fragments. They have not been compressed. There's nothing that's happened to them. All right, part three, compaction and cementation. So the process of making sedimentary rock involves compaction and cementation. So grab your tin foil rock fragment system in your hands or with a book and lightly press and squish the crayon shavings together. I mean the rock fragments together. So I'm going to go ahead and fold this to make it easier for me to compact my rock fragments. So what's going to be happening on Earth is, yeah, rock fragments will be brought to certain places as they're weathered and eroded. But then you have to think, okay, well, once the rock fragments are brought to a certain place, then more sediments are going to fall on top and they're going to start getting compacted, right? So they're going to start compacting down. And then water is going to bring minerals through that rock, and as water is leaking through the rock, it's actually dropping those minerals off, and those minerals are going to bind those rock fragments together. So that's what we call cementation. All right, so let's open it back up and see what we see. Oh yeah, we got like an actual hunk of stuff now. So it looks like a fun rock that you would find at the beach, maybe, something that you could, I don't know, like a speckled rock, a speckled stone. So we have now made our sedimentary rock. It says, how do the layers compare to the layers when we eroded them together? So I would say that when we eroded them, there was still like a mound, right? There's space in between the layers. Now the sediment has settled, and the pressure and just compaction and cementation of those minerals coming through it has squished the layers down. So now they're more distinct layers. What happened to the tiny spaces between the fragments? There's no more spaces between the fragments. They're pretty much gone. Part 4, place your rock fragments back in the aluminum foil if you took them out. All right. And we're on metamorphic rock now, so we're going to be talking about how metamorphic rock forms. So I am holding it back up. It says, what two forces increase to cause the process of metamorphism? That is heat and force. So as more force is applied to a sedimentary rock, or any kind of rock really, it's going to press it more and more together, like fuse it. And then as heat is added to, it's going to kind of make it all mushy together. So it says, fold the aluminum foil over the crayons, rub your hands together and make them warm. This time press down with a lot of force. Do not step on it. You got it. So I'm creating friction with my hands, creating that warmth, and I'm pressing hard. And I'm making it a little bit warmer and much more heavily pressed together. So this is gonna make it not as pretty of layers, right? Because now we're kind of mixing them all together. It's melting a little bit. It's kind of hard to see that with this because it's not the perfect illustration, but in real life, the rock would be a little bit more swirly, maybe you could say, or wavy in the layers. And there's definitely not as distinct of like separate stones or sediment in it because they've been crushed together and then heated up and warmed. What does pressing on the rock fragments mimic? It mimics the pressure as rock goes deeper and deeper into earth. Open up your package, okay. Oh, interesting. Okay, what's the difference from the previous time you squished it? So this is going to be a little bit harder for you guys to see, but now the colors aren't as distinct as they were before. The colors are actually mixing together just a little bit, so I can still see there's green, red, yellow, blue, white. I can still see there's gray, all of that, but now the colors are blending together just a little bit, so I can see that the different layers are a little bit waving together. And again, there's even less space between the sediment now, and it looks more like one sort of rock instead of like all of those different mishmashes together. What is the texture like? Oh, it's definitely a lot smoother. It's not as crumbly as before. It's a lot smoother to touch. And what happened to all the empty spaces? Well, clearly there's not empty spaces anymore. It's been compacted. Definitely, it's been pressed with a lot of pressure. Those empty spaces are gone. Part 5, igneous formation. Unfold your tinfoil and create a boat. I love making boats. So unfold your tin foil and make a boat. That's what I'm doing. And again, you can do all of this at home, so it'd be really fun for you to do with a younger sibling, to show them the rock cycle, maybe show your parents. It'll help you remember the rock cycle too. First you're doing sedimentary, then you're doing metamorphic, now we're doing igneous. So I made a little boat, see? It has a little lip around the whole edge. And it says, fold up the edges so that when we melt the crayons, no liquid can escape. Place your boat on a hot plate at a low temperature. This is at a very high temperature. This is what we call a hot plate. It's used for warming up things. You can't touch the top because it is incredibly hot. So anytime we use a hot plate in science, we have a little grabber, like a test tube clamp or something like that, to grab things off of the hot plate with, because otherwise we will burn our fingers and potentially spill liquid on us that's hot. So it says, what is your hypothesis of what will happen with the increased heat? Well, we learned during states of matter that hot turns things into liquid or gas, but this is a solid, so when I heat it up, it's probably going to turn into a liquid. That's my hypothesis. As the rocks are melting, what's happening to the colors and the layers that we saw before? Well, I guess we'll have to see. So I'm heating it up now, it's getting warm. And just so you know, when this happens, oftentimes there will be smoke. So I guess we'll see what happens. Oh yeah, see there's a little bit of smoke coming. Smoky scent. It's definitely warming up. Huh. Have you guys ever seen melted crayon before? It definitely looks a lot different than crayon that was solid. So it really turns liquid really fast. And what it's doing is it's spreading and the colors are mixing. And so it's not green and red and blue anymore. It's kind of, I guess, all of the colors mixed together. It's not a very pretty color anymore, that's for sure. It's not vibrant the way it was. So this mimics when the rocks are pushed down far enough into the earth to where they actually turn back into magma, and then eventually they'll come out as lava, right? So number 9 says, when the rocks are liquefied, place your tin foil in a cold water bath. That's this right here. What happened as the liquid cooled? So now I do have a pretty good liquid here. I think I'm going to show you guys really fast so that you can see the liquid. It is definitely not pretty the way it was before. It's all different now. It's very hot. I'm going to submerge it in the water. Interesting. So this actually is a very good representation because it looks like lava when it cools. So it has the air bubbles from being quickly cooled, and it has the marks of where the lava was flowing, right? It's really interesting. This looks kind of like pumice, which is the kind of rock that has a lot of holes in it from volcanic eruptions. This is an igneous rock now. And it says, please describe the physical difference between igneous and metamorphic. Well, metamorphic rocks still had wavy layers. They were like not as defined as sedimentary rock, but they were wavy layers, and it was definitely still distinct layers. This doesn't have any layers at all. All of the rock has been completely mixed together. It doesn't look like the separate colors at all. Now it has all become whatever rock was mixed together, like it's just all mixed. And it has air bubbles in it from being submerged and cooled. It has pathway marks, like you can tell where it was flowing from. So it shows motion, I suppose, too.